And today I'll be talking about some lessons learned from commercial CCS projects in North Dakota, which is sort of north central United States, right on the border with Canada. So I'm going to start off with, as he was mentioning there, we are storing CO2 in North Dakota right now. Since February 2022, about 2.5 million tons of CO2 have been stored in North Dakota. And now that CO2 has been stored from four different operational projects, two of which are ethanol plants. One is a coal gasification plant. It's a plant that takes lignite coal and is able to get methane and ammonia and some other products out of that coal. And then the CO2 that's generated as a byproduct is part of it is going up that green line, which is a pipeline to an oil field in Canada. And then approximately 2.7 million tons from that facility are now going into a saline formation. And then Denbury, which was recently purchased by ExxonMobil, they actually have an enhanced oil recovery project going on in the southwestern part of the state, where they inject about 1 million tons a year. So all told, in North Dakota, a couple of these projects are fairly new and they're in the ramping up stage. But by the end of the year, we're looking at a rate of about 4 million tons of CO2 being injected in North Dakota. There's a coal-fired power plant that has its permit in hand for CCS. They're going through the final financial decision phase, and then there are several other projects that are announced that are in various phases of development. When we talk about the business case for CCS in the U.S., we're looking at a combination of tax credits and low carbon fuel standard markets that have credits associated with them. If you're looking at the federal tax credits, that's what we call 45Q. There you can get $85 a ton for CO2 stored in a saline formation for dedicated storage. You can get $60 a ton for CO2 stored as part of an enhanced oil recovery project. And then if you're doing direct air capture, if your CO2 is coming off of the DAC unit, you can get anywhere from $180 a ton for storage in a saline formation to $130 a ton for CO2 in an enhanced oil recovery project. And then those low carbon fuel standards, the LCFS, several states have these. Sort of the premier one is the California Air Resources Board, the CARB LCFS credits. Those have been trading for about $60 a ton. Those can be stacked with your 45Q credits. So for instance, if you've got an ethanol plant and you're capturing the CO2 and storing it for dedicated storage and saline formation, you can get your $60 a ton from selling your ethanol into the California market because you've got that CCS component, and then you can get your $85 a ton for storing it in CO2 for the tax credits. So that gets you a total of $145 of between tax credits and carbon market credits that can go towards your capture, to offset your capture and storage costs. If you're going to do CCS in the US, you've got to have an underground injection control or UIC Class 6 well permit. For most of the country, you've got to go through the US EPA. The US EPA oversees the underground injection control system. However, they do have a process by which a state can apply for primacy, and what that means is the authority to regulate a CO2 storage project can pass from the EPA to a state regulatory department. What that state has to do is demonstrate that their rules and regulations for storing CO2 are as strict or more strict than the EPA regulations. So they go through a process, they submit an application for primacy, and in 2018, the US EPA did indeed approve North Dakota's application for Class 6 primacy. What that means is that the North Dakota Industrial Commission, Department of Mineral Resources, is a regulatory authority for Class 6 wells in North Dakota. North Dakota also has rules in place for pore space ownership. Essentially, the surface owner has rights to the pore space. Those rights are unseverable. They will always be with the surface owner. And North Dakota also has a process by which you can amalgamate pore space owners into an area where you want to have your CCS project. When we talk about underground injection control and Class 6 primacy, right now, North Dakota, that's that northernmost green state there. North Dakota, Wyoming, and Louisiana are the only states that have primacy. Arizona, Texas, and West Virginia are in the pre-application phase, and several other states are exploring it. But what I want to get across here is the advantage of having a state that has primacy. So North Dakota, the regulators in North Dakota, they'll just focus on one or two, maybe three permits at a time. There's only going to be a couple of permits coming in any given year, whereas the EPA is responsible for permits that are submitted all across the other states. And my understanding is that I think they've got around 100 permits that have been submitted that are pending. So their staff is fairly overwhelmed looking at these various permits. Whereas in states like North Dakota, Wyoming, and Louisiana, that staff can just focus on one or two permits, and that enables a more streamlined regulatory process. It's also important to note that the regulatory process in the states with primacy, the data that you generate, the information you pull together, whether it's of a technical nature or a business financial nature, that goes into your storage facility permit. That also is generally geared to meet the requirements of the low carbon fuel standards. For instance, CARB has a sequestration site characterization or certification and a CCS project certification. So if an operator is an eye towards doing that, they can use the North Dakota, they can use their permit application to sort of springboard and integrate with that incentive program. Same thing as with the 45Q. Now, North Dakota will have primacy, which they can issue the permit for CCS. However, if the operator wants to realize and monetize those 45Q credits, the EPA will be involved in that. They have to approve the monitoring, reporting, and verification plan. Once the EPA approves it, then the IRS will accept those CO2 tons injected as being stored and then qualify for the tax credit. So there is an EPA step. So again, that state permit has to satisfy the EPA in terms of the MRV reporting. Real quick, generalized timeline to implement CO2 storage in North Dakota. Again, because we've got primacy, this is fairly streamlined. You're going to start off with you got an idea. Okay, you want to go to this particular location, so you'll start with your screening study. That's where you use your legacy data, your existing well logs, your existing seismic information about land ownership and pore space ownership, information about current surface usage, so you get a sense of whether or not your site will sort of pass that first screening stage. Once you hit the go decision point after that, you get into the feasibility stage. That's where you acquire your site specific data. You'll drill an appraisal well or stratigraphic test well, collect core, run samples and test analysis on those cores, geomechanical testing, mineralogy testing, porosity, permeability, and then do some downhole tests, injectivity tests, downhole geomechanical tests to test the strength of the various sealing formations. And then you also you'll sort of pre-qualify the site. You build your geological model and do reservoir simulations on the amount of CO2 you want to store. You get to that, you realize you've got a plume size that you can work with that's going to fit in the area that you're interested in. So then you move on to your project design and permit application phase. It's anywhere from 6 to 18 months. And that's where you pull together your financial assurance, you qualify the site with more detailed modeling, you do your project design, specifications, your feed study, determine estimates of CapEx and OpEx. That all goes into your project design and permit application. Once you get there, you submit the permits. Here's where the having primacy comes into play. If you submit it to the EPA has no obligation to make a decision on that permit in any set time frame. It could be multiple years before they make a decision. In North Dakota law says that the DMR has to make a decision within 12 months of the permit being submitted. Now, it will go through a hearing process. The hearing process will, comments can be provided by the public and other stakeholders. Those comments will be addressed by the operator. Then it's resubmitted, and then the DMR will make their review. But all of that has to happen within 12 months. This provides the operator with some regulatory certainty in terms of when they can get their project moving along. And of course, once the permit is issued by the state of North Dakota, then you've got your investment and construction phase. That's going to vary depending on the complexity and size of your project. Part of the permitting process, once you do the simulations after the reservoir characterization, you come up with an estimated size of the plume at the end of the project, sort of the maximum amount of CO2 that you plan to store. That stabilized plume becomes your boundary for your to set your storage facility area. You set a buffer outside of that boundary. The operator does have some discretion on how far out they set the boundary. That's generally determined based on the modeling that suggests how far the pressure plume is going to go. Then beyond your storage facility area, you've got a hearing notification area where you've got to let the neighbors know what you're going to do, give them an opportunity to participate in the hearing. And then once you go through all that, you've set your boundaries. Right now, this is a map showing the 5 locations that have permits in hand. 3 of them, the Red Trail Ethanol, the Great Plains Synfuel Station, and the Blue Flint Ethanol are all operational projects. And then those other 2 are permits associated with a coal-fired power plant that's looking to do CCS. I'm going to quickly step through as a case study the Red Trail Energy ethanol plant near Richardson, North Dakota. This is a corn-based biorefinery. And their project has been active. It started injection in June of 2022. Their injection target is the Broom Creek Formation, which is a Permian age sandstone with a permeability that is in the Darcy range of permeability. Thickness is around 100 feet, sometimes more, up to I believe 200 feet in some locations. So you've got a nice thick package of high permeability, high porosity sandstone. That's what they're injecting into. As of March 31st, 2024, about 288,000 tons. So by now, they're probably close to 300,000 tons of CO2 has been injected at the Red Trail site. They comply with all the permits and incentive programs, including, I think, notably the Oregon Clean Fuels Program, which is based or sort of modeled after the California program. And Red Trail Energy is right now going through the process of getting qualified for the California Clean Fuels Program as well. And then they are on the Puro Earth Registry on the voluntary carbon removal market. And one of the things I wanted to get across with the Red Trail project is the timeline. So here's an actual project that went through all the processes to get their permits, to get the site characterized. They drilled a well, they did 3D seismic, they built models, ran the simulations. They put in bids for the capture technology, got a contract in place, got the whole thing built. Capturing CO2, starting injection and doing their monitoring. And all of that was just a little over 3.5 years from the beginning to the end. So, I think it illustrates that if you've got a regulatory process that's focused on getting things done in a timely manner so that financial decisions can be made and reduce that the risk associated with regulations. You can go through all these different steps. You can acquire all the relevant site characterization data, and you can get through it in about 3 years, 3.5 years. That's for the small ones. Now for the big ones, we were recently awarded North Dakota as the center of what's called the Heartland Hydrogen Hub. This is a multi-billion-dollar effort to decarbonize multiple sectors, industrial and agricultural and manufacturing sectors in this region of the United States, sort of anchored by North Dakota and Minnesota, and all while producing clean hydrogen for end use in the fertilizer and power generation areas. And of course, CCS is going to be absolutely essential to this. This is going to be looking at capturing and storing, on the order of 5 to 10 million tons a year of CO2, depending on how many different activities are going on. But this is going to be a big part of the Heartland Hydrogen Hub and really the hydrogen economy in the future. With that, I want to say thank you very much for your attention and